Hi guys, welcome back. We're going to talk about 1.2 day 2, which is the quotient power instead of the power. So we're going to go ahead and hop into our notes here. So just recall from yesterday that 5 to the third times 5 squared is 5 to the fifth, because we kept the same base here and then we added the exponents to get our 5 as the exponent. So if multiplication is the addition of exponents, then division is probably going to be the subtraction of exponents. Okay, so if we're multiplying with the same base, we add the exponents. If we're dividing with the same base, we subtract the exponents. So if I have 5 cubed divided by 5 squared, again, I keep the exact same base. Sorry, my equal sign looked really funny. And then I'm going to do 3 minus 2. And 3 minus 2 is 1. Now, some of us may skip right to that step, and that's totally okay. So what do you notice? We're going to subtract. Another way to think of this and why this works is if we wrote this as a fraction, 5 cubed over 5 squared. 5 cubed means 5 times 5 times 5, and 5 squared means 5 times 5. And we know that 5 over 5 equals 1. So this 5 over 5 would now be 1, and this 5 over 5 would be 1. And 1 times 5 would be 5. So that's why we can subtract them, and it works. Okay? So division is subtraction of exponents. So you have that filled in twice now. Okay, so we're going to, again, do the same exact thing with variables. So this is y to the 7th divided by y to the 4th. Again, I'm going to keep my exact same base, which is y. And then 7 minus 4 is 3. So we just took our exponents because we have the same base, and we're dividing, so we subtract the exponents. Let's go to the next page here. Again, this is just the general way we can write this, is that anything divided by anything else with the same base, we can subtract the exponents. So let's practice some here. So 2 to the 9th divided by 2 to the 6th. Again, I'm going to keep the exact same base. And 9 minus 6 is 3. Same rules apply here when we have a number with no exponent. There's an assumed 1 there. So negative 7 is our base, so we're going to keep that the same. And then 5 minus 1 is 4. Okay. Same thing if we have decimal exponents, so 3.5 is going to stay the same here, and 8 minus 6 is 2. Okay. Now this one, 2 to the 8th divided by 3 to the 6th. I could get an answer for this. There is a number answer for this, but I cannot simplify it in exponential form because I have a base of 2 and a base of 3. So this is as simplified as it is going to go. Okay, so there is no answer for this one. It is simplified in exponential notation. Okay, so you got to be careful. If the bases are not exactly the same, we can't do anything with them with exponent rules. Same thing applies here when we have more than one number. So go ahead and give me a guess on what you think this is based on what you know from the product rule and our quotient rule. So again, remember we can combine h's with h's. So h to the 6th minus h to the, not minus, I apologize. H to the 6th divided by h to the 5th, we're going to subtract the exponents and keep the base. So 6 minus 5 is 1. And then we're going to do our k's. So k squared minus k to the 1 would be k to the 1 because 2 minus 1 is 1. So we could just write that simply as h to the k. If you left the 1s in your exponent, that is absolutely fine. Okay. Same deal here. When we have coefficients, which are numbers in front of the variables, we divide those like normal. So 63 divided by 9 is 7. I do not subtract them. I only subtract exponents. Okay, and then I'm going to look at my x's. Well, x to the 9th, x to the 3rd. 9 minus 3 is 6. And then we're going to look at our y's here, which I'm going to try and do in a different color. Y to the 7th, y to the 4th gives me y as my base, and then 7 minus 4 is 3. So my final answer would be 7, x to the 6th, y to the 3rd. Okay, and I believe that's our last problem. Have a wonderful day, and we'll talk to you tomorrow. Bye. Oh, it didn't